Assalamualaikum. Good morning, everyone. My name is Muhammad Hafiz and Harun. Today, I would like to present my research paper for the title name Image Data Compression Using Discrete Cosine Transform for Wireless Transmission. This is the abstract for my paper. This work aims to propose a suitable image compression techniques and recommend for the best compression ratio as to address the issues of transferring data over a long-range wireless network. A MATLAB code is written to implement both algorithm with input images from the database is tested on the developed algorithm. Simulation results have shown that the input images can be compressed with a different value of compression ratio CR ranging from 3 to 50. These are the sample images that has been used in this work. Golden apple snail are highly invasive and cause damage to rice crops. They were introduced to Asia from South America in 1980s as potential food for people, but it unfortunately became a major pest of rice. Snails are able to spread through irrigation canals, natural water distributions pathway, and during flooding events. So for this study, the idea is to detect the location of these predators, take a photos and transfer the data image to the monitoring base station. To transfer the image data, it needs to be compressed before transmitted over a long-range wireless network. Image compression is a type of data compression applied to digital image. The reason is to reduce the cost for storage or its transmission purpose. Digital images contain with a large amount of data which requires bigger bandwidth. Type of image compression can be categorized into two categories. It can be lossy or lossless. There are so many wireless communication technologies for image data transfer such as Bluetooth, Wi-Fi, WiMAX, Zigbee, Z-Wave, LTE, LoRa and LoRaWAN. The objective of this research are to propose a suitable image compression techniques and recommend for the best compression ratio, to develop the proposed algorithm for detection of golden apple snails images which are acquired from various databases, to analyze the performance of the proposed system, and some of the parameters will be measured in this third objective. From the previous studies, what can I tell here is about LoRaWAN technology is widely used in image data transmission. Most of recent research on LoRa focus on its outdoor performance and coverage. LoRa proved it can deliver more than half packet from 5 to 10 km range in urban applications and in maritime application where 15 to 30 km distance observed. But LoRa constrain 1% duty cycle, which means only can transmit data 36 seconds each 1 hour of transmission time. This is a table show the comparison between two types of compression. By looking at this information, I can conclude that the lossy image will be losing some of original data. The quality will be reduced by amount rate of compression, but it is still good enough to identify the object in the image. For the lossless compression, the output images area almost the same as input. It only apply low compression rate, but in this study I will focusing more on lossy image compression. My proposed method on this paper, I have using the technique called fast Fourier transform FFT algorithm. By applying the FFT algorithm, the DFT calculation can be shortened. In this case, the looping process can be reduced. The FFT structure for speedy computation of DCT. So it is suitable for large input images. DCT computation methods. This approach is using DCT2 functions. The first simulation in MATLAB, I am used the first sample grayscale image with 512 times 512 pixel. This is the image segment 8x8 achieved after doing the DCT2 functions. This 8x8 segment is identified by their own and row column. After that, in the written coding MATLAB, the DCT image coefficient will be changed into this value. By simply making the small value to 0, we will get another value of this image coefficients. This process has been written in the algorithm code which will be used in this work. This is actually the compression ratio value threshold. The main purpose is to neglect the small value to 0 is to achieve image compression. This is the previous work done by Aladdin and Hassan in year 2016, and this is the work done by Nadim, Salman and Gufran in year 2014. They propose quantization and smoothing factor techniques to get the image compression. They are using two sample images for baboon and cameraman. For this work, here is the result from the simulation that I have done with FFT coefficient neglected below than 30 value. If we can see here, yellow-green indicators show the DCT coefficient of the images before truncations. The dark blue color indicators show the DCT coefficient neglected from higher frequencies to low frequencies, which is the images has been compressed. As a result, the original image size of 176 kilobytes has been compressed to 125 kilobytes by using FFT based approach with the truncation value below than 30. To get more values of compression ratio, I was using 5 different truncation value to one simple image. Here I am using 10, 30, 50, 70 and 90. It shows that the truncation value of below than 90 is the higher compression ratio I get if compared to the previous work done by the other papers. Paper 10 has proposed 3 different lossy compression algorithms on one single image where the size used is 4 to 5 times 318 pixel. In the experiment, DCT method is the lowest compression ratio with 38.13 and the mean square error is 14.25. These 3 methods were using multiple threshold value in the proposed technique. Paper 11 has proposed a quantization smoothing where they have 2 different images A and B. The image A is a photo of baboon and B is a photo of cameraman. Both photos were applied with different value of quantization smoothing factor. The compressed image A has the higher compression ratio 34.66 and give lower PSNR value 29.12. But in my work, the pixel 8x8 image has been used while the original size of 176 kilobyte has been compressed with 5 different values of truncation using FFT algorithm. As a result, truncation value E gains the highest compression ratio. The higher truncation value is applied, the more compression ratio will be gained. As the conclusions, the value of E will be used to transmit over a long range wireless network because of the size of image has been reduced to 89.7 kilobyte, which is the smallest among the others. And that's all for my presentation. Thank you.